2A, ionic Lewis structures. What type of elements make up ionic compounds? That would be metals and nonmetals. Struggling with my spelling. What type of ions do metals form? Metals always form cations, and nonmetals gain electrons to form anions. So when you write your ionic compound, it's always the metal and the nonmetal, which is really a cation and an anion. Cations are positive, anions are negative. Draw the Lewis dot diagrams for the following elements. Lithium has 1 dot, boron's in group 3A, it has 3 dots, nitrogen's in group 5, it has 5 dots, helium is in group 8, but it's not big enough to have 8 valence electrons, so it has 2. Neon is in group 8, and it has 8 valence electrons. So now we're going to draw the Lewis diagrams for the following ionic compounds. We'll start with KCl. We draw the Lewis dot diagrams. Cl has 7 valence electrons and K has 1 valence electron. The metal always transfers to the nonmetal, so K becomes a plus. Cl will have 8 dots around it, and it's a 1 minus charge. You could look on the periodic table for the 1 plus charge and the 1 minus charge. The metal is always some type of plus. The nonmetal is always in brackets, always has 8 dots around it, and always will have some type of negative charge on it. CaO. Ca has 2 valence electrons. This oxygen has 6 valence electrons. These two will transfer there, such that oxygen now has 8 valence electrons. Keep them fenced in, and that oxygen gained 2 electrons, therefore it's a 2 minus. And the calcium lost 2 electrons, it's a 2 plus. Let's scroll down to C. So CaF2. Ca has 2 valence electrons. There's 2 Fs. Each F has 7 valence electrons. 1 valence goes there on Ca and 1 valence goes there. Final answer, Ca has a 2 plus, and you have 2 Fs bracketed in to keep those electrons that it just kind of stole from calcium in. So you'll have 8 dots around the F, and each F is a 1 minus. So 1 times 2 plus is a 2 plus, and 2 times 1 minus is a 2 minus. This goes on in your head as your way to check if you're on target. A 2 plus cancels out a 2 minus, which is neutral. That's what we did when we were naming in the last unit. Let's move on to letter D. Na2O. So we have 2 Nas. Each Na has 1 valence electron. There's 1 O that has 6 valence electrons. I gave it 1 too many. And 1 valence will go there from sodium and 1 from the other sodium. So you have 2 sodiums that are each a 1 plus because they each lost 1 electron, and 1 oxygen that now has 6 valence electrons, and it is a 2 minus. And again, you check. 2 times this is a 2 plus in your head, and 1 times a 2 minus is a 2 minus. 2 plus and 2 minus cancel. It's neutral. Let's move on to Al2O3. So we have 2 Als. Each Al has 3 valence electrons. We have 3 Os. So what I know from the Al2O3 is that it always pairs up as 2 aluminums to 3 oxygens. Each oxygen has 6 valence electrons. So maybe those 2 valence go there, those 2 valence go there, and those 2 valence go there, such that you have 2 Al with a 3 plus because each aluminum lost 3 electrons. And then you have 3 bracket oxygens. Each of those oxygens now has 8 valence electrons, and they all gained 2 electrons, each oxygen did. So 2 times 3 is 6, and 3 times 2 is 6. It's a little bit like, again, when we were trying to name or write the formula from the name. K3P, 3 Ks. Each K has 1 valence electron. 1 P has 5 valence electrons. So 1 valence there, 1 valence there, 1 valence there. So you have 3 potassiums with a 1 plus. And then you have 1 phosphorus in brackets with 8 valence electrons, and it's a 3 minus. Final answer. Notice the 3 and the 1 and the 1 and the 3. They're kind of opposites, so it's neutral.